Hello to everyone. I'm happy to be here. I'm proud to be here. Because my time is very limited today, then I go straight away to, and I would like to invite you to code with me today. What we are going to implement today is authorization in an Angular app. Before we jump directly into the code, a few words about myself. I come from Wrocław, Poland. I work for Capgemini for over 15 years now. I'm an architect and a developer, full stack, but what I specialize is are web solutions in general. Okay, let's jump now into what I would like to show you today. First, I would like to tell you once more time, maybe for many of you, what is the difference between authentication and authorization. So authentication checks who the user is, while authorization checks what the user can do. Today we will focus only on authorization. Okay, let's jump to our demo. What I have is an Angular application, very simple, with the backend. The backend has 3 endpoints: login, logout, and current user. And I have my frontend, and the application is already protected. I mean, the authentication is already implemented. This means that if I log in as admin, and by the way, password is not password1234. Then I'm in my application and I'm admin, and I have 2 dialogues. It's extremely simple: the home page and the admin panel. But the problem is that if I log as a regular user, I can also access the admin panel. And this problem I'm going to solve right now. So let's jump to the code. This is a typical Angular applications, a few dialogues, nothing more, nothing less. I'd like to show you 2 elements which are important when talking about authorization on the client side. A little disclaimer: generally speaking, about security, we talk about security. Your server side must be secured and protected at all times. The client side is exposed through the browser. That's why this is more like just user experience thing than the security itself. Okay? So first thing is I'd like to show you how to protect routes in our application. In our application, we have actually 4 routes: login, access denied, which will be used for authorization when something goes wrong, when a user will not have specific rights or roles for a given route. And so these 2 routes should be public, while these 2 should be protected and should be available only for a regular user or only for admin. So now, first thing we have to do in our application is to express somehow our authorization rules. Second, we have to check these rules against the current security context. So now the first question is how to express what routes are allowed to which user roles. Well, let's try to answer this question asking ourselves, how would we express it in code? My idea I'd like to share with you is to put it directly in our routes. So assume we have our login page component. I should say permit all true. The same for access denied. While for the home page component, I'd say access allowed to, and here I would typically put the role of my user. So I am prepared, I have already role enum. Today I learned that this is not always the best idea, but in this case it just works. So the home page component is available for regular users, while the admin panel only for users having the role admin. Of course, it doesn't compile right now, so let's try to fix it. My idea is to extend the routes. Today we learned that libraries can publish interfaces. Also for that reason that it can be extended, and this is exactly what we are going to do right now. I have my security model somewhere here. For example, I defined here a role and a user, which is extremely simple. But in addition to this, I will put right now an interface. I will name it authorized route, which extends a route and adds here the elements we used right here to express our rules. Oh, sorry for that. So it will have permit of type Boolean, which is not obligatory, is optional, and the same for access allowed to. In addition to this, I have to put also children, because we learned that JSON likes trees, but Angular and especially router does too. That's why we have tree structures, and here we have to also define authorized routes. So here what we can see are routes. If we go to the definition, we see that they define a convenience type for routes. So let's do the same for us. Let's go again to our model, and let's define a type called authorized routes, sorry. And let's use it right here, and let's import it. And what is missing? Okay, thank you. Yeah, right, thank you. Okay, so this is the first step. We expressed our rules about the authorization. Now the solution, which is very well known, is to use guards to protect our routes. So let's implement one. Authorization guard is nothing more, nothing less, just a regular class which implements can activate interface coming from the router. If we implement all the members, which is only one method can activate, we see the API, how the API looks like. Let me shortly explain what it does. As a parameter, we need actually only the activated route snapshot. So this is the current route, which is going to be guarded. And regarding the API, let me just explain it like this. Let me first import all the elements which are needed. And the API is like the following. If we return a boolean from can activate, it means either can activate or not. If instead of false we return a URL tree, it means, okay, you can't activate this route, but you should go under this URL expressed by the URL tree. And of course, it can be also asynchronous or observable, and that's why we have this return type. Now, what authorization guard actually is, it's a regular Angular service. Because we would like to inject here our security service, our security context, then we need to decorate this guard with a decorator called injectable and use it to provide this guard in the root context, in the root injector. So now let me inject our security context, which is already implemented. Let's make it available as a property. And now let's jump right here. So let's say, let's return false as a default, which means everything is protected. And now let's take the route and the current route which is guarded right now, and let's take the config from that. Which is, in fact, our authorized route. That's why we can, here we can see that null can appear. That's why I will be a little bit defensive and I first check if config is truthy. And then I can check if config permit all, then of course return true. Else, if the role is defined, then we can use our security service and we can check the role against the currently logged in user, against the current security context. Okay. And this is almost perfect. The only thing is that we would like to not just block a given dialog if authorization roles are not sufficient. Instead, we would like to navigate to a special dialog, access denied, just in case. So that's why in all cases when we return false, we would like to now return URL tree, which leads us to this route. That's why let's define in our class a private read-only access denied page URL tree like this, and let's try to set it in the constructor. And in order to do it, oh, I have some typo. In order to do it, we will need also the router service. Which has a convenience method called parseURL, where we can just say, hey, this is our route, this is our URL. And now the only thing we have to do is to put this instead of false. And also in this case, we have to apply additionally just a map operator, which just takes in case this is true, we just return true, but if it's false, it just returns, not this one, but this one. Okay, done. Good. So now, it's pretty simple, pretty straightforward. All we have to do is to add this can activate guard to our routes, like this. Okay, let's check. If we log as admin, we should see everything, while if we log in as user, we should land on access denied. Okay, it works, but I'm not happy with this solution, because having this information here, for example, if a developer forgets to do it, then of course the security doesn't work. The general rule in the security world is everything which is not allowed, is everything should be protected by default, and only as a whitelist we should say this is allowed, this is disallowed. So let me implement just the final element here, and let's remove first these guards, and instead, wouldn't it be nice to have something like this in our app module? What we could do, we could inject again our router service, and wouldn't it be nice to have something like enable security for routes passing the router. And let's try to implement very fast. Let's export this function. Functions are beautiful. And the router service should be passed here. So the idea now, how to do it automatically, is to get our routes directly from the service. Do something with these routes, and eventually reset the config with our guards implemented and set. Like this. And now we have to go through the tree of our routes and add our guards, which we have implemented in an automatic way. So let's traverse the tree. Lucky me, I have it implemented before. For
Marek, 30 seconds.
Sure.
Lucky you.
And what I should put here is a tree root. So 30 seconds. Okay. Can manage it. Okay, so maybe I will switch to the solution and 1 minute more, okay? Because I... Oh yeah. So when we implement this function, when we do something like this, then our routes will be automatically, to our routes, automatically our authorization guards will be added, so no developer can make a mistake. So this is one thing. And another thing is what I did was, maybe I will show you just a demo. If I log in as user, now it works like before. Even I provided here some mechanism, some structural directive for that. Show you, this is the last element, really. So I implemented also such directive, very similar to if access allowed to, and thanks to this fact, we can also add our authorization rules on components, not only on routes, but on components. And the third puzzle piece in the puzzle is the service. So all these three elements build up the authorization in Angular applications. Thank you. The code is available here if you're interested in that. Thank you.